Hello guys, this is Edexcel Science channel and now we are at question 16. A simple hydrometer is a cylinder with a mass at one end. The cylinder floats vertically in a liquid. The diameter of the hydrometer is x. A scale on the side of the hydrometer shows the vertical position of the hydrometer in the liquid. So this scale is going to tell us how deep the hydrometer is inside the fluid. A student placed the hydrometer in a sample of pure water. Complete the free body diagram. Okay, so we know that if an object is in a fluid, there is going to be always an upward upthrust. And all objects will have a downward weight. Now, one thing we need to keep in mind is that the length of both of the arrow must be equal. Why? Because this hydrometer is actually floating. Floating means that it is at equilibrium. Equilibrium means that all the forces on the hydrometer is balanced. Since these are the only two forces acting on the hydrometer, both of them must be equal in length so that they cancel each other out. To demonstrate this in our free body diagram, we need to make sure that these two lengths are equal to the eye. It does not need to be absolutely exact. Question number 2. The student placed the hydrometer in a sample of seawater. Seawater is more dense than pure water. Why? Because it has salt dissolved in it. At equilibrium, the vertical position of the hydrometer was higher in seawater than in pure water. Now, we know from the question tells us that seawater is more dense than pure water. Okay. Now, how much an object is going to be inside the fluid depends on the upthrust provided by that fluid. We know that the formula for upthrust is density of the fluid, volume of the object times g. Now, if the density of fluid increases, that means the upthrust is also going to increase. Why? Because upthrust is directly proportional to the density of the fluid. Therefore, since the density of seawater is greater than pure water, a smaller amount of fluid needs to be displaced to provide the same amount of upthrust that pure water would have provided. So even though the hydrometers are the same, for seawater we need to displace a smaller amount of liquid to provide the same amount of upthrust. Therefore, to write the answer, it should be something like the upthrust is equal to the weight of the displaced fluid and the upthrust is equal to the weight of the hydrometer, because we drew it in question number 1. So upthrust is equals to the weight. Therefore, a smaller volume of seawater needs to be displaced because seawater has greater density. That is how we answer this question. Question number 2. Hello guys, this is Edexcel Science channel and we are at question 16b2. Calculate the change in vertical position of the hydrometer when moved from pure water to seawater. So what they are trying to tell us is when we moved the hydrometer from pure water to seawater, as we can see that there is a change in height. They want us to find out this change in height. The way I want to approach this question is I want to find out this depth first, and then I want to find out this depth, and then I want to subtract each other to find out h. So how do I find out how much deep is the hydrometer in pure water and seawater? So at first I'm going to find out the mass of the hydrometer. They have provided us the weight, so mass of hydrometer is 0.324 divided by 9.81, which is going to give us 0.033 kilogram. Now we know that whatever volume of pure water the hydrometer has displaced, we can find it out using this formula. Density is equals mass divided by volume. So over here we can find out volume is equals mass divided by volume. So 0.033 divided by the density of pure water is 997, which gives us 3.31 times 10 to the power minus 5. So what I have done is I found out the mass of the hydrometer. Now I know that density is equals mass divided by volume, and we can find out how much pure water is being displaced to balance this mass. So this is the calculation. Next we are going to find out how much is the depth. What is the depth over here? What is the depth over here? Now this is the tricky part, because most students would not think of this way, but at the beginning of the question they gave us a hint. They gave us the diameter of the hydrometer. There was no reason for them to give us the diameter, but now they have. That is why it should tell us that we have to use the volume of the hydrometer, which should be pi r square L. From here we can find out L. So V divided by pi r square. So 3.31 times 10 to the power minus 5 divided by pi, and the radius would be half of this. So 1.23 divided by 2 times 10 to the power minus 3 to convert it to meter whole square. This will give us 0.28 meters. So this is the depth of the hydrometer in pure water. We are going to repeat the same process. We are going to repeat the same process for seawater. So for seawater, the volume, this is pure water, this is volume of seawater, would be 0.033 divided by the volume, sorry, the density of seawater which is 3.22 times 10 to the power minus 5, and volume is divided by the radius which will give us 0.27 meters. This actually we should take it to more significant figures. This is 0.2786 and this is 0.2710 meters. Now that we know that in pure water it was at this depth and in seawater it was at this depth, so to find out the change in length or change in height, we can just subtract them. So it becomes 0.0076 meters. That is our answer.